On the screen you have Maths Box set 2 for the 10 questions, and I will walk through and explain those questions to you and how to answer them. Express 0.000000423 in standard form. That means we need to write it in a standard format. So, for example, you can think of that as a standard format, and there are 3 features of a standard format. So I will just give an example that's different from our question to demonstrate that standard format for you. Okay. So if we had 8.13 times 10 to the power of 5, there are 3 parts of this that tell you that it is standard form. One is that the number at the front, the integer, the digit at the front, is between 1 and 9, and it is never 0. If it is 0, then the number is not written in standard form. There is also only one number in front of the decimal point. So if there are ever 2 numbers in front of the decimal point, it's not in standard form. The second feature is that there is a times by 10, and that is essential too. And the third feature is that there is a power of 5 or any power, and it can be negative. So those are the 3 features of standard form. Now, our number at the top is clearly not in standard form, so let's get to putting that into standard form. Now, we have a 0 at the front, and that's not correct. So we need to move forward until we see a number that is not 0. So here we have 4. That tells us that we need to put 4 in front of our decimal point, and the 2 and the 3 will follow. The second part of our standard form, remember, is to have times by 10. And the third part is to have a power. Now, how we decide on that power, one of 2 things. If there's a 0 at the front of your ordinary number, that means that it's a very tiny number and it's under 1. If it's under 1, we work with negative powers. If there was a bigger integer in front of the decimal, like a 1, 2, 3, 4, or 5,000, then we would be working with a positive power. Now, we need to decide now on what number goes next to that negative symbol. And we do that by deciding how many places that decimal point has moved to get to here. Okay, it's gone once, twice, 3, 4, 5, 6 times. Okay, so we can say that 0.0000423 has the same value as 4.23 times 10 to the minus 6. Okay. What that means, the times 10 to the minus 6 means that you're dividing by 10 6 times. If it was a positive 6, it would be timesing by 6 10 times. Question 2, expand and simplify x plus 3 in bracket by x plus 5 in a bracket. Just to remind you that actually means that the 2 brackets are being multiplied together, because multiplication in maths is lazy, and if the multiplication involves a letter or a bracket, it doesn't bother showing itself. But it is assumed that you will know that it means multiply. So we're going to have a look at 2 methods first of all. So on the left-hand side, we have the grid method. A number of you will be using this for your multiplication already, but we actually can apply that in algebra as well. So the multiplication gets mentioned here. And what we do in the row at the top and the column down the side is we put the details in of what we're multiplying. So if we've got x plus 3, I'm going to choose to put the x and the positive 3, the plus 3, here. You could choose to put it down the side. It doesn't make any difference. And I'm going to put my x and my positive 5 at the side here like that. Okay. Right, so what we will now do is we will multiply the row and the column. So if you go across from here and down from here, so that indicates that we're going to multiply the x and the x together. Just a reminder that x times x is x squared. If that's something you still struggle to remember, you need to focus on your indices law, and that will help your algebra skills. So x times x is x squared. So we'll move across to this box here, and we'll work down here. So this is where we have x times 3. So x times 3 is 3x. It is a positive 3x because it's a positive 3. And that will help when we take it out of the box and put it in a straight line. Okay, moving down to the positive 5, or the plus 5. So we've got 5 times x, which is 5x, and it's a positive 5. And then we've got 5 times 3, which is 15, and that is a positive, oops, pen working again, is a positive 15. So like I said, let's take those 4 terms out and put them in a straight line. So we put the powers at the front, and then we'll list the x's, and then we'll list the number that's on its own at the end. That's your standard way of writing algebra out. However, we have expanded, but we haven't yet simplified. So that would get you 1 mark in an exam. To get the second mark, you need to tidy it up a little bit. So that's collecting the same terms, the like terms together, and adding them together. Now, in the same way that apples are different from bananas, x squared is different from x. They are just different items. So you cannot add x squared to an x. So as we only have 1 lot of x squared on there, there's no mention of x squared anywhere else. I'm just going to bring that one down. We can do something with this, but we'll come back to that in a moment. Now 15 is a number on its own and there's no algebra attached to it. And there are no other numbers on there that are not attached to algebra, or that are not attached to a letter. So we can bring that straight down as well, because that's not able to be added to any of the other terms on here. In the middle, we've got the 3x plus the 5x. So that's 3 things plus 5 things. So that's 8 of them, and it's a positive 8x. So the answer to the question, and I'll write that up here at the top, is actually x squared. Can I just get my pen working? X squared plus 8x plus 15. So the question is actually equivalent to that. Now, some of you at school may have learnt this a different way. You might have learnt something called FOIL. So let me talk through FOIL with you. Now, a lot of the students that say that they remember FOIL don't actually remember what FOIL means. And actually, you don't need to know what it means. You just need to know what to do. But let me explain it anyway in case that helps you understand. So we have first, that's what the F represents. Then you have the outer. Then you have the inner. And then you have the last one. So it gives you an order to do the multiplication in. Okay. So the first one would be this one. So that would be the x times the x. So it's just the same calculations we did in the grid. Now, personally, it can be helpful to have notes on the side just to check your thinking as you go along. You don't have to. And I'll just put down my notes so you can see what my brain's doing. So my first part there that I just explained was I'm going to times the x by the x, and that gives me x squared. Okay, so I'm also going to pop that underneath and start to create the line straight away. So we've done the first one. Now we're going to do the outer one, and that is x times positive 5. So x times positive 5, I don't need to put plus on a positive 5 because we know that's positive, gives me 15x. So pop it. Does it? It gives me 5x. Sorry. That gives me 5x. My brain went there, jumped to the next part of the question. Right, so we've done the outer. Now the inner is these two here, the inner two numbers. So that's a positive 3 times the x. So positive 3 times x equals 3x. And we'll bring that 3x here. Okay, so we've done the inner, and now we're going to do the last one. The last one we haven't yet done is the 3 times the 5, which gives the 15 that popped into my head a moment ago when I said the wrong thing out loud. Okay, so on my right hand side I've got my little notes, but underneath the brackets you can see we've ended up with the same thing as we did down the bottom of the grid example. So by the same token, we still do the x squared and the positive 15, and then we would then go on and simplify in exactly the same way as we did in the last question. So 2 different methods to solve the same question. Now, I've only got the red pen set up here today. You might choose to do a different colour for the first, the outer, the inner and the last, and that might then help you focus on the right thing. Okay, do remember that where there's a symbol like an operation like a plus, so on this one here the plus belonged to the 3, and on the second bracket the plus belonged to the 5. So if that had been a subtraction, it would that would have been a negative 5, for example. So just be a little bit careful that you don't ignore that symbol that's in between, because it can change the answer in the end. Now, question 3 is factorising. Factorising is the reverse process of what we just went through with expanding and simplifying. So we just did multiplication, so factorising is in fact division. You might prefer to see it as putting the brackets back in. Let's just jot that down at the top. Okay, there are some worked examples that you can print off that go alongside this video. Okay, and the first thought process is, what is the largest whole number that goes into both 42 and minus 66? Okay, so what is the number that goes into both? So what we're looking for are factors, hence the word factorising. So if we look at factors of 42 to start with, so if we go here, so what numbers multiply together to make 42? Always start with 1, because 1 and 42. 2, fingers and thumbs allowed, and 21. 3, and if you're not sure if 3 goes into 42, do a little division. 3's into 4 go once with 1 left over. 3's into 12 go 4 times, so that's okay. Okay, so just a good little way of just double check. Everyone seems to think that they have to do everything in their head, and you don't use paper. 4's, well, if I halve that, I get 21, and if I halve that, I get a decimal answer, so that won't go into it. 5, no, it doesn't end in a 0 or a 5. 6, yep, 6 times 7. Okay, good. 8 doesn't go in, it's not in the 8 times table, and it's not in the 9 times table. Okay, so we've got all the numbers that go into 42. I know that says negative 66, but for the moment, let's just pretend it says 66. So we're looking now at numbers that multiply to make 66. This gets a little bit trickier, but here we go. So we've got 1 and 66, 2 and 33. If I divide that by 3, I get 22. Can I divide it by 4? Well, let's test it out. If I divide it by 2, I get 33. If I halve that, I get a decimal number. So 4 does not go into it. 5 doesn't go into it because it doesn't end in a 0 or a 5. 6 goes into it 11 times. 66 is not in the 7 times table, the 8 times table, or the 9 times table, or the 10 times table. So we know we've got them there. So what we're now going to identify was, what's the largest number that we see on both sides? 7 is not on both sides, 14 is not on both sides, 21 and 42. So in fact, 6 is the largest number that you can see on both sides of that working out. So what that means is that we can divide this by 6 and get an answer that looks something along the lines of that. We don't, so 6 will go here, and we need to work out what goes inside the bracket. So that's basically what it means. Okay, so there's a couple of ways you can do it, and you can actually use the grid to think this one through. So remember, when we're multiplying, we multiply something in here and something here. to give an answer. Well, we've got our answer. Our answer is 42x, and it's negative 66. We've just worked out that 6 goes into it. So 6 times something gives us that answer. Okay, so that's what we need to now work out. So we have 6 here. What do we times 6 by to get 42x? Well, 6 times 7 gives us 42, but we also need to times it by x. Now, 6 times what makes 66, or 66 divided by 6? So I think that's right. That actually gives you an answer of 11. But what we do have is we've got negative 66. So because 6 times 11 is 66. So 6 times minus 11 will give us minus 66. So there you go. You've got your answer there. So hopefully that helps. Okay. Now, other people might work through this in a slightly different way. If you're happy with that method, I'd stop there and move on. But we can walk through this a little bit more quickly. So here we've got 42 times x minus 66. So what we just did, essentially, is we worked out that 6 lots of 7 times x gives you 42x. And we had 6 lots of 11 gives you minus 66. And when we put it in the bracket, what we do is that we divide this by 6, and we divide that by 6. There you go. I didn't mean to do that. There you go. And what we're left with goes inside the brackets. Okay. So you might find it easier to do it that way. And I know a number of you that I've taught possibly do that process in your head, and that's okay as long as you're getting yourself to the correct answer. So now we have work out 456 divided by 19. I've given you the answer of 24 there, and let's show you how we get to that answer. So most people will be familiar with bus stop method, and that looks something like this. Okay, and it's deciding which number goes in. So actually, the number that goes in is the one that's at the front. Doesn't matter how big or small it is, the one at the front is always what goes inside the bus stop. Okay. For this question, you won't need this next bit, but I would encourage you to do this to prepare you for answers that are going to give you a decimal answer. So if you have a whole number going in the bus stop, get in the habit of putting a decimal point and a couple of zeros. I'm picking a pen that actually does work the way you want it to. Okay, and make sure that decimal point is there at the top as well. Okay. Also, if you're like me and you've managed to make that rather small, or if you're a little bit messy on your working, give yourself plenty of space. So that 456.00 is better when it's spaced out that way, because the working that you have on a question like this can get a little bit messy. Now the 19 goes on the outside, so hopefully that format to look at is something you're all familiar with. Now what we need to do here is actually work out what a 19 times table is. The reason I say that is it stops you having to repeat working out what 19 and 19 and 19 is in your head as you go through the question. I don't expect you to know the 19 times table, so this is how I would suggest you do it. Well, we know we're starting off with 19. Hopefully you know that 19 times 10 is 190, and that's the highest point you need to get to. I would suggest on a piece of paper that you actually do this alongside. So if we add those two together, we get 38. So that's the second one. And then we add 19 to that, we get 57, and so forth. So I'm going to carry on working through this one until I get until 190. 20 take away 1 is 76. That's another way of doing that. Okay, we've got to 5 times, so we just need to keep going. If I don't hit a 190, then I know I've made a mistake in my addition. So if you're not confident in your addition, the 1, there we go, and that gives you 3 and the 1, and then practice repeated addition, because that will help speed up this process. Let's a bit boring watching me do this. I do apologise, but you know, things take time in maths, and sometimes you've just got to give it the time to work it through in a logical way. There we go. So that's going to be 152. 152. We're getting close. So we're almost up there now. That's 171. And then that takes us up to 190. Phew, I haven't made any mistakes. All right. So now you've got all of that calculation worked out. So by the time you actually start doing the division, you've got a lot of the hard stuff completed. Right. So the first question is, how many 19s go into 4? Or 4 divided by 19 equals what? Well, we can't give an answer to that because you can't get a whole number answer from that. So we make that 0, but we haven't yet shared out the 4. So we need to carry that forward. In the same way as if you went shopping and you hadn't spent all your money in the shop, you wouldn't leave it behind, you'd take it with you. So now we need to look at how many 19s go into 45, and that's where our list on the side really helps. So 45 sits here. So we can see straight away that we've just got 1 lot, 2 lots of 19 there. So 2 lots of 19 goes into 45, but let's have a look. 2 lots of 19 is 38. We actually had 45. So how many have we got left? We've got 7 left over. So we take that 7 forward to here. And now we're looking at how many 19s into 76. And very conveniently, that one is already here. So that one is 3 times 19. That is 4 times 19. So our answer is 24. Okay, we didn't need to carry forward after the carry on after the decimal point in this case. We've got a whole number answer. But had you needed to, you would just continue on in the same way. Question 5, increase £340 by 5%. So just going to highlight this word because sometimes that gets forgotten when it actually comes to answering the question. Okay, again, increase. And we're working on 5%. So this is a non-calculator skill within the 10 questions. So I'll first of all look at the most common non-calculator method. We're actually going to start looking at 10% of £340. Okay, now 10% is one of those really special percentages where you can literally just divide by the number at the front. You can't do that with any other percentage. If it's 20%, you can't just divide by 20. It won't work. It's only 10% that works with. Okay, so if we're working out 10% of 340, we can simply do 340 divided by 10, and that gives you 34. Okay, divided means move the decimal that way. 10 means that you're moving it just once, hence the 34. Some of you might just see that answer in your head, and that's fine. So 10% equals 34. 5% is half the amount. So that would be 34 divided by 2. 10 divided by 2 is 5. So 34 pounds divided by 2 would give you 17 pounds. Okay, so we've worked out what the 5% is. And if you just put 17 pounds, you might pick up a mark, but you wouldn't get your full marks because you actually need to increase 340 by that amount. So we go back to the original 340, add the 17, make sure you show that in your exam, and that will give you £357. Okay, so not everybody likes to use that method, so let's have a look at another way that can be done without a calculator, but might be slightly trickier to do than the one we've gone through here. So remembering that 5% as a fraction is 5 out of 100. All percentages are out of 100. So if we're working out 5% of 340, we will be working out 5 hundredths times 340. Okay. So that means, those of you that remember your fraction knowledge, is you start with this number here, 340, and you divide down, DD, divide down times the top, divide down times the top. So 340 divided by 100. So 2 zeros moving that way means a decimal point goes once, twice. Gives me an answer of 3.4. We need to take that answer and times it by the top, TT. So 3.4 times 5 equals, well, okay, you're not sure how to do that. I'll walk through that as well. We have got one decimal place in these two numbers. So if I temporarily remove that decimal place and work out what 34 times 5 is. Okay, so I've got 5 times 34. 5 times 30 is 150. 5 times 4 is 20. If I add those two together, I've got 170. So that equals 170. Put the one decimal place back in. There you go. I've got 17, just as we had on the opposite side. So now that you know you've got 17, we complete the question. We have 340 plus 17 equals 357. See, both of those can be completed without a calculator. The one on the left is the one a lot of us do in our head already, but many students will have learnt to do it the fraction way. So,
question 6. A measure is stated as 5 meters correct to the nearest meter. Find the lower bound. Okay, you can see here that I've highlighted two key parts of this question, one being the nearest meter and one being the lower bound. But then there is obviously another fact here I haven't yet circled, so there you go. Right, so there are the three parts that we're going to actually use for this question. So the measure stated as is stated as 5 meters. So let's pop that piece of information in the middle. Okay, and it's correct to the nearest meter. So that means that it could actually have been less than 5 meters or more than 5 meters, but when rounded to the nearest meter, it became 5 meters. Okay, so let's look at which point you change from rounding to 4 meters or 5 meters, or from 5 meters to 6 meters. And the clue here is we're looking for the nearest meter. So when we write nearest meter down, that way would be the 4 meters, and the nearest meter that way will be one up from 5 meters, which would be 6 meters. Okay, so the point that we would round up or down falls exactly between those two. So that would be 4.5 meters here would round up to 5 meters, and 5.5 meters here would round up to 6 meters. Okay, anything else would go in the opposite direction. So what we actually have here is a lower bound and an upper bound. So basically, if you had a pipe that was cut and measured, and you said it was 5 meters and it had been rounded to the nearest meter, that pipe could be as little as 4.5 meters in actual length, or it would be just under 5.5 meters at maximum length. Okay, so that's how you would answer the question for lower bounds. The lower bound on this question is 4.5 meters. Okay, it's in the other videos, but you might be asked to express that as an inequality. This is not part of this particular question at the moment, and how that translates is it means the value that the 5 meters is greater than 4.5 meters. It could also be equal to 4.5 meters, and x is smaller than the 5.5 meters. So if you want to extend your skills, that's how you would take that question further. Question 7. Find the next two terms in the sequence 33, 31, 29 and 27. Probably the simplest of the sequence type questions. Okay, and it simply involves looking for the pattern between the existing numbers here. Most people will probably recognise that they reduce by 2 each time. So we continue that sequence. 27 take away 2 is 25. Take away another 2 is 23. Okay. Question 8. Find the y-intercept of the line 2y equals 2x plus 8. This is something that can be completed without a graph, and you can do it by identifying the key features of that particular expression. But what we have here is an issue that we need to deal with first of all. We have 2y equals 2x plus 8. To be able to identify the y-intercept correctly, we need to have an equation that actually states y equals, not 2y. So what we need to do first is divide the top equation by 2, so that we have 2y divided by 2 gives me y. We need to do the same to the other side. So 2x divided by 2 is x, and 8 divided by 2 is positive 4. Okay, and now we can identify our y-intercept, which is 4. And what that basically means, if we have a look at a graph here, across here, now we know what our y-intercept is, and it's where the y-axis is 4. That means the line 2y minus 2x plus 8, or y equals x plus 4, cuts the y-axis at that point where y equals 4. So that's your y-intercept equals 4. Question 9, solve simultaneously x plus y equals 5 and 3x plus 2y equals 13. Okay. So if you can see, I've highlighted the first equation in green, and we're calling that equation 1, and the second one is equation 2, and I've brought those down onto my working space. Okay, so the first thing I'm going to look at when I get a simultaneous equation is whether I have got same number of x's or same number of y's in both equations, so matching x's or y's. Oops. We don't in this case, so in that case we then need to move on to considering whether we're going to scale up one of the equations until we have something that's matching. You can choose whether you want to work with matching x's, or you can choose whether you want to work with matching y's. It doesn't matter, you choose and just stick to that one, which to match. Okay, x or y. So I'm going to opt to choose to match my x's. Okay, so if I times the first equation by 3, it would then become 3x. So that's what I'm going to choose to work with. Okay, someone else might choose to multiply up the y's by 2, and that's your choice, and that's fine. So my choice is to times this equation by 3. So equation 1 becomes equation 1 edited. So x times 3 gives me 3x. Y times 3 gives me 3y. It's important I multiply the whole equation by the same multiple, okay, multiplier. And 5 times 3 is 15. Okay, so I'm going to work with that new equation there, and I'm just going to pop the others up out the way. Okay, I am, however, just going to lazily copy, there we go, that equation and bring it down here. So I'm going to work below the line now. Right. So I have two equations that share the same value of x and the same value of y. I've got 3 x's in the top one and 3 y's in the top one, and I have 3 x's in the bottom and 2 y's in the bottom. So if I were to subtract one equation from another, what would happen would be I would cancel out my x's, because I'd do 3x take away 3x is nothing. 3y take away 2y would give me 1y. And that's 1y, which is the same as y. Then I'd have 15 take away 13. That would give me a value of 2. So basically what that tells me is that the y value in both equations is 2. So now we can use that information to find out what our x value is worth. So to just go through here, we didn't have matching x's and y's, we scaled up, we chose to match with the x's, and then we cancelled by subtraction out the x's by subtraction. So let's just clarify what we just did. Okay, we subtracted it because they were both positive numbers. If you have a negative number in there and a positive, you may well have had to add them together to cancel them out, but this time we cancelled by subtraction. Okay, then we worked out the value of y, and now we need to substitute that y value into one of the equations, and again you can choose any of the equations to find the value of x. Okay, obviously I'm writing that out so that you can see my thought process. It can be a helpful little checklist to have. So let's pick the original equation 1 here at the top. So that equation said that x plus y equaled 5. We now know that y has a value of 2, so if we put that in there, that means x plus 2 equals 5. And you can do the maths there. 5 take away 2 means that x equals 3. And that's now complete. And the final question of the set is to work out 3/5 plus 1/3. When you're adding or subtracting fractions, you cannot simply work across. The bottoms of the fractions, the denominator's got a different value. One is a 5 and one is a 3, which means they can't simply be added working across. What we need to do is make sure that both equations have got matching bottoms or matching denominators. And there's a couple of different methods that you can use to do this. So 3/5 and 1/3 are the two fractions that we're going to change, and what we're going to do is we're going to create an equivalent fraction for each of them that gives them a matching bottom. Now 5 and 3 multiply together to make 15, so on that basis I'm going to give them both a fraction with a denominator, a bottom of that value of 15. Okay, so let's start with 3/5 first of all. Okay, to enable me to change from 5 to 15, I would have had to times by a certain number, and that number was 3. So what we need to make sure is that we also times the top number by the same 3 to get an equivalent fraction of 9/15. Basically, if you did 9 divided by 15, you would get the same decimal answer as 3 divided by 5. So they have exactly the same decimal value, although they look different. And the key point is that's the case because we have times the bottom by the same number that we times the top by. Okay, so now let's go down to our third and apply the same rule. So what do we need to times 3 by to get to 15? Well, that needed to be times by 5. So I have to times the 1 by 5 also, and that would give me 5 out of 15. So our 3/5 and 1/3 is equivalent to 9/15 and 5/15. And now you can see they've got matching bottoms. We can simply say that we've got 9 plus 5 on top, which is 14. And the 15th remain the same. If you think of the 15th as an item, we've got 9 items plus 5 items. That gives you 14 items. Now, some of you may actually have chosen, or learnt or remembered or been taught a different method at school. Okay, so I will go through that method with you also. So let's just pop a little box around this one to separate that out. Okay, that's right. And we will do the same for over here. So this one's like the butterfly method. Okay, so this one involves working with the 3/5 and the 1/3. Okay, and we'll sort of draw a butterfly, see if I can do this as tightly as possible. So we have this one here, and then we have this one here, and then we have the 1 at the bottom. Okay, so we start with the 3 and the 3, and what you do is you times the 3 by the 3 here, and the middle plus sits there. Then we do the 5 times the 1, and then for the bottom of the fraction we do the 5 times the 3. And in a moment you'll start seeing some of the numbers we've already worked with using the other method. Okay, so let's simplify that somewhat. So we have got 3 times 3 is 9. Okay, we've got 5 times 1, which is 5. And we have 5 times 3, which is 15. So that if we go back to our example on the left hand side, we've got the 9 and the 5 and the 15 that we were working with before. Okay, so then on top we've got 9 plus 5 gives us the 14, and on the bottom we simply now have 15. So we've got exactly the same answer, but we've written it in a different way.